Good morning, everyone. This is Dr. B. Haribabu, Assistant Professor, Department of Mathematics, Place Institute of Technology and Sciences. Today, I am going to discuss about the topic minimum spanning tree. So, let us see the definition of minimum spanning tree. Minimum spanning tree. So, first, what is a tree? A tree is a connected graph without circuits. A tree is a connected graph without circuits. So, let us see one example. It is a connected graph without circuit. So, it is a tree. Now, it is also a tree. Let us see this graph. It is a connected graph with a circuit. So, it is not a tree. Next one, spanning tree. So, spanning tree is a tree which contains all vertices of that graph. So, let us see. So, this is a graph. So, spanning means it contains all vertices. Spanning means it contains all vertices. So, it is a spanning tree for this graph. Now, minimum spanning tree, which means a spanning tree with a minimum weight in a weighted graph is called minimum spanning tree. So, a spanning tree with a minimum weight in a weighted graph is called minimum spanning tree. Let us see example. This is a connected graph and weighted graph. So, weighted graph means the edges having some weights. So, let us see 2, 1, 3, 4. So, this is a connected weighted graph. So, for this we can draw different types of spanning trees. So, let us see one spanning tree. This is 1, this is 2, this is 3, and similarly we can draw another spanning tree. This is 4, 2, 1, and we can draw another spanning tree. So, this is 4, this is 3, this is 1. Now, these are all the different type of spanning trees. So, what is the minimum spanning tree? Who's having minimum weight? So, that spanning tree is called the minimum spanning tree. So, the weight of this spanning tree is 1, 2, 3, that means 6, and here it is 7, and here it is 8. So, we have three different spanning trees with three different weights. So, when we observe the minimum weight is 6. So, this spanning tree is called minimum spanning tree. Minimum spanning tree. Now, to find the minimum spanning tree, we have two algorithms. Prim's algorithm, and second one is Kruskal's algorithm. So, first we see Prim's algorithm. So, in Prim's algorithm, first we choose any vertex arbitrary. So, first we choose any vertex arbitrary and then add minimum weighted edge on it, then add a minimum weighted edge on it. Now we are in the second vertex. So at the second vertex, use the same procedure, add a minimum weighted edge on it without having circuits, or cycle. So at the second vertex, add the minimum weighted edge on it without having circuits. Continue this process, continuing this process until last vertex covered, last vertex covered, last vertex covered. So this is called Prim's algorithm. So the first point is choose any vertex arbitrary and add the minimum weighted edge on it, and at the second vertex add minimum weighted edge on it without having cycle or circuit. So continuing this process until last vertex covered. So let us see one example. Let us see one example. Let us take one weighted graph. This is A, this is B, this is C, this is D, this is E. The weights are, this is 1, 2, this is 3, and this is 4, and this is 3, and this is 4. So this is a weighted graph. So for this we have to find the minimum spanning tree by using Prim's algorithm. Prim's algorithm. Prim's algorithm. Prim's algorithm. So in the first step, choose arbitrary any vertex. Choose any vertex arbitrary. So I am choosing A here. So in the first step, choose a vertex A. Then we observe in the main graph what are the edges incident on A. There are two edges. First one is 3 and the second one is 4. So we have to take this edge A to B. So the second step is add A to B edge to this graph. So adding A to B, with weight 3. Now we are at B and we observe the incident edges on B. There are two edges. First one is 1 and the second one is 4. So add B to C edge having weight 1. So the next step is add B to C. So take the same graph A to B having 3 and B to C having weight C. Now we are at C. Now we are at C. So we have two edges having the weights 2 and 3. So what is the minimum weight here? 2 is the minimum weight. So add C to D such that no cycle formed. So if we add C to D, we doesn't have any cycle, so that add C to D in the next step. So the next step is add C to D. Now take the same graph A, B, 1. See, this is 1, this is D, and this is 2. So this is the next step. Now we are at D. So you see there are two edges 3 and 4. So what is the smallest weight? Is 3. So add D to E to the above step such that no cycle formed. So we don't get any cycle, we are not getting any cycle, so that add that edge. So add D to E to the above graph. This is A, this is 3, this is 1, this is C, and this is D to D to E adding 3. So now we are at E. Now we are at E. So E, there are two edges. C to E one edge and E to B there is another edge. So if we add E to C, we get a cycle. So if we add E to C, we get a cycle. So we don't add this edge. Now there is another edge, E to B. E to B, then we get a cycle. Then we get a cycle. So stop the process. So until already we covered a last vertex. So it is the minimum spanning tree. And one more important point is, if the graph having n vertices, the minimum spanning tree having n minus 1 edges. So we have to check that condition also. There are 5 vertices. So in the minimum spanning tree, we must get 4 edges. So clearly 1, 2, 3, 4 edges. So the weight of this is the minimum spanning tree. The weight of the minimum spanning tree is 1 plus 2 plus 3 plus 3. So that is 9. So this is the minimum spanning tree by using Prim's algorithm. So first choose any vertex arbitrary A, then add the minimum weighted edge incident on that vertex. Then next vertex B, add the minimum weighted edge. Then at C, add the minimum weighted edge such that no cycle formed. And next add the minimum weighted edge. So until covered the last vertex. So this is the required minimum spanning tree using Prim's algorithm. So next algorithm is Krishkal's algorithm. Next algorithm is Krishkal's algorithm. We see the same example. So first we see the procedure, Krishkal algorithm. Krishkal's algorithm. Krishkal's algorithm. Krishkal's algorithm. So the procedure is, the first point is list all the edges with their weights in the increasing order. In the increasing order. So the first step is list all the edges with their weights in the increasing order, and then first we take least weighted edge. So first we take least weighted edge. Then the next point, then next add the next least weighted edge such that no cycle formed or no cycle formed. So next add the next least weighted edge to the previous one such that no cycle formed. So continuing this process. until last edge covered. So continue this process until last edge covered. So Krishkal algorithm. So first we have to list all the edges with their weights in the increasing order, and then first we take the least weighted edge, that is the minimum weighted edge, and the next add the next least weighted edge to the above edge such that no cycle formed, and then continue this process until the last edge covered. So let us see the uh, minimum spanning tree for the same problem. So the first point is list the edges and weights in the increasing order. So first least weighted edge is B to C 1 weight. So first we write B to C weight is 1. Then the next one C to D weight 2. C to D weight 2. Next one A to B weight 3, and then C to E weight 3, and D to E weight 3, and then we have the remaining two are there. Those are A to D 4 weight, and then B to E 4. So the first step is list all the edges and weights in the increasing order. And now the first point, the second point, this is the first point, and the next point is first take the least weighted edge. So what is the least weighted edge is here? B to C is the least weighted edge. So add B to C, add B to C. So initial step we take B to C, and we observe the given graph. So B to C. Now the next weighted edge, next smallest weight is 2, which is from C to D. So C to D, if we add C to D to the above, we are not getting a cycle. So add C to D, add C to D. So this is B to C and C to D. So the weight is here 1, the weight is here 2. So add the next smallest weight. The next step is add A to B, add A to B such that no cycle formed. So that add A to B, so that this is B, this is C, this is D, this is 2, this is 1, then add A to B, this is 3. Add the next weighted edge A to B. The next one is C to E. So if we add C to E here, C to E, we are not getting a cycle. So add C to E. Now we get A to B, this is 3, B to C, this is 1, C to D, this is 2, C to E, this is 3. Okay, we added C to E having the weight 3. So the next edge D to E, D to E. So if we add D to E, if we add D to E, we get a cycle. So if we add D to E, we get a cycle. So don't add this edge. Don't add this edge. So this is D. Okay, this is 3. Similarly, if we add A to D, if we add A to D, A to D, if we add A to D, we get a cycle. So don't add this A to D. Don't add A to D also. Now the last edge B to E. So if we add B to E here, B to E, again we get a cycle. If we add B to E, again we get a cycle. So don't add this edge also. So we covered all the edges. So which is the required minimum spanning tree, which is the required minimum spanning tree with the minimum weight. So 1 plus 2 plus 3 plus 3. So it is the 9. So it is the minimum spanning tree by using Kruskal algorithm. So what is the procedure here? So first list the edges and weights in the increasing order. Take the least weighted edge P to C, then add the next weighted edge such that no cycle formed. So continue this process until last edge covered. So this is the procedure of finding minimum spanning tree. Thank you.